for David Stringer, and he's not here, so I guess I'll have to do his job for him. Welcome to R-2000, the Better Built House. My name is Oliver Drerup. I'm an R-2000 builder, and what we're going to be looking at today is the way in which various trades work in an R-2000 setting. It's very important to coordinate those trades, and I think you'll find it interesting. Let's take a look. Builders don't build their houses in isolation. It takes a large number of people to do this job properly. That's particularly true when you look at an R-2000 building. Consider what it is that we're trying to accomplish. First, we obviously have higher levels of insulation. Sort of goes without saying. But also we have airtight construction, which means we have a controlled ventilation system. We're looking at higher efficiency furnaces in these buildings. And of course, we're trying to make the best use we can of passive solar gain. Now, I'm very proud of the buildings that I produce, very proud of the R-2000 stamp of approval, and I'm very proud of my team. I think that's true of an awful lot of builders across the country, and I think you're going to be very interested in meeting some of the people who form the team for the builder on this site. Hey, Danny, I'm glad I caught up to you.
Hi.
How you doing?
Pretty good.
Good. I want to talk to you about the electricals in these buildings. We're trying to put in a continuous air and vapor barrier in this structure. Let's start right at the beginning, where the electrical power comes into the building. What do you do in electrical entrances? What's different?
Well, the critical area is make sure that the air vapor barrier is continuous, and to ensure that we put a backer board behind the electrical panel to protect it. And before that's installed, we make sure that the vapor barrier is caulked to the conduit that comes into the house.
Okay, so the process would be to put the poly on the wall after the conduit runs through.
That's right.
Then very carefully seal that, and then you're putting plywood or a backer board over that.
Yes.
And then you surface mount your box.
That's right.
What do you do inside the conduit itself? Using duct seal, something like that?
Yes, we use duct seal to seal up the conduit itself to prevent air from entering the house.
Yeah, I've seen that in air infiltration testing, when you actually everything seems to be pretty well sealed, but you get a lot of leakage right through the conduit itself.
That's right.
In single stud construction, what do you do with the exterior wall in single stud when you got to put a box in there?
Well, the idea is to try to avoid it, but in situations where we have to make special allowances. We use special precautions, such as the box that you see down here. Basically, this is an on-site constructed box, which is wrapped in poly.
It looks like a lot of messing around there with all this caulking and stuff.
That's right. Well, actually, we tried it on-site and found it very time-consuming and very difficult to do. So what we came up with is this, which is basically the same idea, but we're using the wood of the box itself as an air barrier, and we are sealing up the joints.
Okay, so you're relying on the wood itself to do that job.
That's right.
Then where do you seal the main air vapor barrier?
Well, the main air vapor barrier is sealed to the face of the box. Okay. And another precaution that we have to take is make sure that the box is installed flush with the studs. Make sure that we also like to install it so it's loose, so that when the drywall is put on and the screws installed into the box, so make sure that the screws have the power to pull the box tight against the back of the drywall. Otherwise, the seal will break and we'll get leakage through there. Excellent. Something I hadn't thought about at all. And then you allow the electrical box to protrude out of that. That's because right. You want to be able to pick it up with your drywall. Exactly. First class. What else do we have to know about single stud construction? I guess that you have to be a little careful about the 1/3, 2/3 rule here, because you're really putting the vapor barrier in behind this electrical box. Yes, exactly. To ensure we might not even put any insulation into the box itself to ensure that the vapor barrier is on the warm side. So you're always keeping it warm. That's sure. Okay, well, single stud, I guess the big deal here is to try and keep the boxes out of the outside walls, but what happens if you've got the vapor barrier and air barrier on and then you're strapping on the interior? And in that situation, the electrician's job becomes a little bit more easier because he doesn't have to work with these boxes anymore. But he has to use shallow electrical boxes. Yeah, I don't suppose he has to drill with studs anymore either, because he can pull the wire. That's right. And those shallow boxes would be used if you were using something like that. This is the shallow box for a 2x2, right. And this would be a regular box for 2x3, but you're only able to make a single electrical connection in the shallow ones. Exactly. Yes. So,
avoidance is the biggest deal. What about the ceilings, pot lights and stuff like that? Any problem there?
Well, there is a very big problem with pot lights. In fact, we try to avoid them if at all possible.
So you go for track lighting, that kind of stuff?
Right. Yes.
You just tell your clients that you don't really want to get it in there?
No, because you can't seal it. You can't make sure that the vapor barrier is continuous on the pot lights.
Well, plumbers generally don't run pipes in the outside wall, but I'm going to go talk to a couple of plumbers and see where they do have to go through the outside wall, what they have to do. Thanks a lot for your time. I appreciate it.
Thank you.
I'm going to go find a plumber. Hi, John.
Oh, hello, Oliver. Good to see you.
Good to see you again. You know, I've been going around talking to a bunch of different tradespeople regarding the way in which they view the R-2000 program and any difficulties they're having getting this continuous air barrier. Plumber's a pretty key issue in that, so you seem like an appropriate person to talk to. How long have you been plumbing?
I got here about 7:30 this morning.
Right. No, I mean, how long have you and your dad been plumbing?
Oh, we've had a family business for over 40 years now.
Mm-hmm. Well, you've seen quite a lot of different kinds of houses. How do you find this R-2000 business?
The R-2000, I find it quite intriguing. We've been working in it for 2 or 3 years now, and I'm quite enjoying it, actually.
Doesn't present any unusual problems to you?
It's not the problem so much as things that we have to be considerate of.
Such as what?
Such as penetrations in the vapor barrier.
Okay, well, as a builder, I know that I always wind up getting a service coming in from either my well or the city water, and I've always got a plumbing stack. I suppose that those are two right there.
Well, if we can limit it to those, plus the hose bib for watering the lawn, then we're doing quite well.
So you're trying to avoid getting any more penetrations into the barrel than you need?
Yeah, we're trying to run the plumbing in the inside walls as much as possible.
Well, what do you do when you actually come to one of those penetrations? What do you do, for example, with the plumbing stack?
With the plumbing stack, we use a neoprene gasket, such as this one. We run the stack through the hole in the center and nail the rest of the stack to the blocking that's been put up around it so that we can attach the main vapor barrier to the neoprene.
Yeah, I've seen this before. I use the same kind of technique. This is actually something that normally comes on a roof, but you're applying it at the vapor barrier.
That's right, because the stack actually expands and contracts with heating and cooling. We have to have a flexible joint to keep the stack sealed.
Gotcha. I've used this same neoprene in places where I get, for example, city water coming in, unless I'm bringing it through my concrete slab. Do you use that too?
What we usually do is take a piece of plywood, drill a hole very close to the size of the pipe, run it through and caulk it so that we get a nice rigid joint so the pipe can't move around.
Okay, so what that really means is that in summarizing all those exterior openings, we can use the neoprene gasket for the plumbing stack, for any kind of hose bibs that we've got, possibly for an interior entry from a city or from the well, unless you're going through the slab. Are there any other issues we should be concerned with?
On the interior, the bathtub is the big issue.
And what's the problem with the bathtub?
Well, as you know, the bathtub is put in very early stages of construction, so you have to make sure that the insulation and the vapor barrier are in place and blocking there to allow the rest of the main vapor barrier to be attached to it later. Then putting the bathtub in is standard procedure, except for we want to try and put the plumbing for the bathtub in an interior wall.
Okay, so if you have a situation where you got something like a 5-foot tub that's backing on an outside wall, you got to make sure that you get the barrier in there first.
That's right.
Okay, now that pretty well takes care of the entire envelope. We understand what's happening with the various holes and penetrations going through it and at the tub. Are there any concerns once you get inside the building from that?
The only other system we have to look at is the domestic hot water system. And there we're using higher insulation values on the tanks, and we're using either forced air combustion, or sealed combustion, which means that air is brought from the outside through the appliance and back out.
Okay, this is if you're not using an electric tank and you've got some material you're combusting in the building, you got to be really concerned about the health and safety issues.
That's right.
I got the picture. What about the supply lines coming off that?
We have to watch out for standby losses out of those lines. So at the tank, we often use a P-trap, which means we come up a few inches across the top of the tank, down about a foot before we go off with the supply line. And then we can also insulate those pipes either with the wrap or with the foam insulation to minimize heat loss and condensation.
Got you covered. Listen, I got to go talk to some drywallers. I really appreciate your time.
My pleasure. I get paid by the hour.
Yeah, right.
Take care.
Jeff.
Oliver, you scared me. How are you?
Didn't mean to, I'm sorry. I'm walking around the project here, talking to various tradespeople, trying to find out how they like this whole energy conservation business. And my understanding is that you do both the insulation, the air barrier, and the drywall.
That's right, we do it all.
Well, let's take them one at a time. How do you find the insulation?
The hardware store. I'm just kidding. It's not much different than conventional construction. It's just, as with everything else, with energy-efficient construction, it's how you go about doing it, how you go about putting it in. You have to do it carefully. With the insulation, just make sure it's fluffed out, that it's not compressed in there, and above all, don't leave any gaps.
Okay, no convection in the system.
That's right.
And the air barrier?
That's a little bit of a radical departure from conventional construction. It's not a vapor barrier you're putting in, it's an air and vapor barrier. And because it's an air barrier, it has to be airtight. And that means three things. One, it has to be continuous. Two, you have to seal it and caulk it at all openings, doors, penetrations, that kind of thing. And three, you've got to plug all the holes you're making it while you're putting it up.
You bet. And I suppose you can make an awful lot of holes with those sheets when they come in sometimes.
Careful.
Well, I've had that happen to me. How about the drywall?
Once again, just being careful during the installation. Make sure you hit a stud. And you don't want to puncture that vapor barrier or air barrier at this time. Another thing we like to do is cut for all our penetrations away from the wall. That's a big one.
Yeah, a lot of the guys up my way are using laminate trimmers, which makes a lot of dust, but it really works well.
Good idea.
It's obvious that you've got to deal with electrical boxes in the exterior walls, but what other areas in the building would you have concern for?
With the thicker wall systems, I think door openings, window openings, and an interior attic hatch require a lot more detailing.
Yeah, you can really make a mess of those poly wraps. The windows, it reminds me, have drywall return side and top a lot. That's different, eh?
More money, more time, a little bit more time. Going to cost you a little bit more money, but no, the end result's worth it.
So as far as you're concerned, it's not that big a deal, any of these three things?
No, just take a little bit more time, be a little bit more careful about how you do things, and basically it's conventional construction.
Makes sense. That's the quality product.
That's right.
Thanks a lot for taking your time. I didn't mean to scare you. I gotta go see if I can find my co-host. He got lost.
Drop by anytime, Oliver.
Take care. Look who's here. The host is back.
Hi, Oliver.
How you doing, David?
Okay.
That's a heck of a sunburn you got there.
Yeah, I guess I must have got a little too close to my research.
Passive solar.
Yeah, that's enough about me. How did you do without me?
Well, not bad for a builder, but I could have used more time.
I guess when it comes to builders and talking, there's never quite enough time, is there? But what do the people have to say? Can you summarize it?
I think so. I talked to a number of tradespeople, and they all say yes, there's more care and attention that goes into these buildings, but it's not onerous. Nobody's having any trouble with it.
Yeah, I sense a kind of a commitment from the guys who are like built a few and are into the system. In the next program, we're going to talk to even more people. We're going to talk to, hey, you'll like this. We're going to talk to some builders. There are other builders in the world.
I'm shocked.
Yep, and we're going to talk to some people who actually live in completed R-2000 houses. So join us next time on R-2000, the Better Built House.
I wonder how he got that sunburn. Hey, David. David? David, how did you get that sunburn?
Well, I was, like I told you, I wanted to understand passive solar. And I thought the best way to understand passive solar would be to really throw myself into it. Yeah, well, now I had to go to a place where the sun's rays were high in the sky all the time because, you know, I didn't want to waste time, you know, for waiting for cloudy days. So I went to the small island in the Caribbean, and I observed first.